Hi everyone, we're going to analyze the graph of the rational function r to the x equals x over x minus 1 times x plus 2. This is where the numerator we would call p to the x and the denominator is q to the x. The degree in the numerator is 1 and the degree in the denominator is 2. Because if I pull this out, I get x squared plus x minus 2. So the degree here is 2. All right. And this is our number 2. And I'm going to go a little faster on it. We're going to do these steps. What I'm going to do on this step is just set up intervals in case you can't use a calculator. And then we're going to graph this. Also, you need to know how to do step 4 because I kind of go through that fast. I do have a video on this that's separate. Okay, so the first thing, we're going to find the domain of r to the x. And the domain is just going to be all real numbers. We can just put the x there. But x cannot be 1 and x cannot be negative 2. And the reason for that is because if you plug in 1 or negative 2, you would be dividing by 0, which we can't do. That's undefined. It's already in its lowest terms. And so we're going to start with step 3 on the next slide. So we're going to find step 3. And we're going to find the x-intercept by letting y be 0, or rx be 0. So we plug this in. When you cross multiply, you just get x equals 0. And when you plug that back in, we'll have our x-intercept at 0, 0. The same thing happens with the y-intercept. Everywhere there's an x, you plug in 0. Basically, you get 0 over negative 2, which is just 0. So the y and x-intercept are the same. Okay, we're going to test for symmetry in step 4. So step 4, this is where you replace everywhere you have an x, you put negative x. And I think I'm going to rewrite this. Makes it easier. I'll just pull this out. X squared plus x minus 2. So everywhere I'm going to plug in negative x. You get negative x over negative x squared minus x minus 2, which this is going to be equal negative x over x squared minus x minus 2. Since it's neither our original, it doesn't look like our original, neither does it look the negation of the original, so there is no symmetry. All right. Step 4, it's already in lowest terms. So we have step 4. We have to reduce it. And it's already reduced in lowest terms. And we already know our domain. So our vertical asymptotes are whatever in the denominator equals 0. So our vertical asymptotes are x equals 1 and x equals 2. Okay, and we're going to do step 5. And that is find the horizontal asymptotes. Since my degree in my numerator is 1 and the degree in the denominator is 2, that means my n is less than my m, or I can say 1 is less than 2. Therefore, my horizontal asymptote is y equals 0. Now, to see if it intersects the horizontal asymptote, we set our equation to 0. And basically, we just get x equals 0 when you cross multiply. So it does intersect, and you plug the 0 back in just like we did before. So our x does intersect at 0, 0, which is the intercept, basically. Okay, step 6 means you're supposed to use a calculator. I am just going to do it as if I couldn't use a calculator. And I'm going to pick intervals. So I'm going to pick the intervals. At negative infinity to negative 2. And because that's where our vertical asymptotes are. And I'm going to go to 0 and go from negative 2 to 0, then 0 to 1, and then 1 to infinity, which goes that way. All right. So basically, I'm picking my vertical asymptotes, and I'm also picking my horizontal asymptote is y equals 0. So I'll tell you what I'm doing here. So basically, if I do a little line here, I'm picking negative 2, because that's a vertical asymptote. I'm picking 1, because that's a vertical asymptote. And I'm picking 0, because that's the horizontal asymptote. So I need to know what the behavior is going on. And I'm going to choose the numbers. So choose a number. I'm going to pick negative 3 here, negative 1 here. Here I had to pick 1/2, which is the easiest, and then 2. Now, I'm going to find the value of r. So here I'm going to plug in negative 3, find out what my y is, or my r. That means the location on the graph is below the x-axis. And therefore the point on the graph would be negative 3, comma, negative 3/4. All right, and I chose negative 1 here. And I plug it into my equation, and I get 1/2. It's positive, so that means it's above the x-axis. And my point's going to be negative 1, comma, 1/2. Here I picked 1/2, and that's going to equal negative 2/5. That means that's below the axis. That point is 1/2, comma, negative 2/5. And on the 1 to infinity, I'm picking 2. R of 2 equals 1/2. And that's above the axis. So we have 2, comma, 1/2. And the last step is we're going to graph this. So I graph my vertical asymptotes at x equals negative 2. And x equals 1. So this was x equals negative 2. And this is x equals 1. I had a horizontal asymptote at y equals 0. It does cross, remember. Okay, this is y equals 0. Now, I'm going to go from this side. We had the points negative 3, negative 3/4. So about right here. And this side does not cross. And so it's just going to go like that. The asymptotes just frame your graph. From -2 to 0, I picked -1 and I got 1/2. So this is going to veer up to here. Okay. And it does cross at 0, 0. Not doing a very good job here. All right. It does cross at 0, 0. And then I have a point. So this point here was, this should have been more in here. That point is -1, 1/2. This point here we did was -3, -3/4. Now the point in here that we did was 1/2 and -2/5, so right in here. So it never can cross the vertical. So the point I did here was 1/2, -2/5, and the point I picked in this interval was 2 1/2, which is here. So it veers like this. All right. So here are your graph. Okay. Thank you. Have a nice day. Bye-bye.